Seeking English, S.A.T. Workbook, page 470, problem 2. It says no calculator, and I must ask you to please do try this problem with no calculator before reaching for your calculator, as a certain number of students inevitably will want to do. The part in which you would actually be able to use the calculator, amusingly enough, is the part that where I'm likely to go wrong in this video because of noise and other distraction today. I don't teach class during the noisy times of day. I do make my videos during the noisy times of day, so there could be some noise at any moment. Okay, it's probably going to get noisy when I get down to those simple arithmetic processes that should go automatically and don't. So sympathizing with my struggle at the easy part of this problem hopefully will make you feel somehow more confident during the test. It says the equation. Okay, and this may look like another problem in the book. They're different enough that they're both in the book for a reason. And if I get a special request, I will make a video where I compare the two problems. I might need a bigger board for that. So in the meantime, no special request, no such video. That's your equation. It says the equation, and it says is true for all values of x, except for x does not equal minus 1 over a. That's means that at minus 1 over a being equal to x, that x does not work. It says, or you must assume that it does not work. They've told you to. Where a is a constant, means a is a fixed value. What is the value of a? That means that even if you change the x, it will not change the a. So at the beginning of the process, your equation has an a, it has some real numbers, and it has some x stuff in it. And at the end of the process, you want a on one side, and you want the real numbers on the other side, and you want all that x stuff gone. One way to get rid of x is to try to cancel all the x's. If you don't see any immediate way to do that, neither do I. And between the two of us, probably I would. The other way to get rid of the x is to put a real number in for it, which is permissible according to the design of the problem. So it says there's this one x that you don't want to put in, but we won't tell you precisely what it is. If you knew what a was, you would know precisely what it is, but then you wouldn't have to do the problem at all. So we don't know what precisely is the number that we don't want to plug in for x, but we know that it's one of a set of 4 possible x's, 4 plausible x's. So if we just don't put in any of those 4, we won't be putting in that one that we don't want to put in. So if you can see, I wouldn't put in any of those x's anyway. Okay, great. You're a step ahead of most students. Okay, let's take a look at what they would be. Things just before we start to plug things in for x. Things that we don't want to plug in for x. It's going to be x equals, and the first one, that's it. If this is a, then this goes in here. Minus 1 over minus 7. Okay? And those negatives can cancel, and you get, I'm just going to notate it again on almost identical notation. 1/7 is a number you don't want to plug in for x. I don't really need to do the others, I'll just explain them. 1/4 is a number you don't want to plug in for x. Okay. Negative 1/4 is a number you don't want to plug in for x. And negative 1/7 is a number you don't want to plug in for x. Now I can imagine there might be some problem on some test where there would be a clear reason to plug in one of these 4 numbers, but it's not likely to come up when you're taking the real test. Your first instinct shouldn't be to plug in any of these 4 numbers anyway. Okay, we're going to plug in something for x. This is going to be a quick review of what numbers to consider plugging in and why. Okay, don't plug it in yet, but consider plugging in the number 0, because if there's no reason not to plug in the number 0, 0 has a tendency to make a lot of things disappear. Okay, and as a rule, making things disappear is good. You want to get it down to an a in some area. It means something's going to have to disappear. So part of the process is making things disappear. This, in many problems, would make many things disappear. Reasons you don't want to plug it in, there's the complex reason that you don't want to plug it in. I'm not going to go there. A simpler reason is this. If you plug in 0 for x, all your a's are attached to x's. Both of your a's are attached to these x's. If you plugged in 0 for x in the problem, that is in the process of solving for a, you would eliminate any definition of the thing that you're solving for. And this xa would become 0a plus 1. This would just become a, hey, it would go really smoothly, but at the end of the process, you wouldn't have a. So don't do that. I hope that this is clear to everyone. It's clear to some of you, of course, immediately. Some of you it's not, and you're the ones I'm talking to, okay? There's nothing wrong with you if it was not clear to you immediately. I just need you to try to understand this before the test happens, okay? You plug in 0 for x, then a goes away, and you don't want that to happen. You don't. So, your next instinct in the test, hopefully, will be, can I plug in the number 1? And from there, you go, as a matter of judgment, to a -1 or a 2. The idea is that. Start with the simplest integer, which is 0, and then move away from it in other simple integers until you get to something that the design of the problem doesn't forbid or make impractical.